Okay, in this section we are going to cover money problems, and this section is very similar to wet mixtures, dry mixtures, and all of the word problems that we have been doing. You're going to encounter a word problem that looks something similar like to this. In example 1, the cost of 5 boxes of envelopes and 6 boxes of notepaper is $16.75. 3 boxes of envelopes and 4 boxes of notepaper cost $10.75. Your objective is to find the cost of each box of envelopes and the cost of each box of notepaper. For this, we are going to continue with Mr. Nguyen's example of the pot, or in this case, we'll make them shopping carts. Okay. And we've all gone shopping before, so we know that whatever we put in our basket and whatever other items we put in our basket, we're all going to have to pay for. So at the end of the day, what you would like to do, what I'd like you to do, is to make sure that what you're putting in is the amount or the number of, before we said number of pounds, in this case it's going to be number of boxes of envelopes. And in this box we can say, hey, we'll put in the number of note papers, boxes of note papers. And they all have costs associated with it, and sometimes your cost is different. So you're going to have different costs for different items. Okay, and I would go about this by making sure that we label our information. Okay, let's say this shopping cart contains envelopes, boxes of envelopes, and this one contains note paper. Okay. So in setting up our equation, we're going to be, working in the same fashion, multiplying down, adding across. So when we put our information in, what's really important is, let's take apart the paragraph. In our first sentence, you have 5 boxes of envelopes and 6 boxes of notepaper, cost $16.75. The number of boxes that you would put in first is, and I'll use red for the very first sentence, you have 5 boxes of envelopes, so I'm going to put a 5 here. And you have 6 boxes of notepaper, so I'm going to put a 6 here. And the cost, I don't know what that is. I'm going to make that X dollars. So X dollars will represent the cost of my envelopes. Y dollars will represent the cost of my notepaper. Okay, but I do know that the total here is going to be $16.75. Okay, so what I've done here is I've actually formed the skeleton of what my first equation will be. Okay, so my very first equation, and I'll write it down on the side, is going to be 5 times x, which is 5x, plus 6 times y, equal to what you would pay at the register, which is $16.75. Which makes sense, you have to pay per box, and you don't know how much that is, but you're going to have to pay 5 times that amount. Same with note paper. You don't know how much it costs, but whatever it is, you're going to have to multiply by 6 because you're purchasing 6 boxes. All together, this is your total charge. So we cannot stop there because we have a second set of information to consider. The second sentence reads, 3 boxes of envelopes and 4 boxes of notepaper costs $10.75. So once again, I'm going to have another shopping cart. Okay, and I know that I'm going to have a shopping cart of envelopes and a shopping cart of notepaper. Okay. And in my shopping cart, I'm going to have in this sentence 3 boxes. So the number 3 boxes here, and I'll make this in blue. 3 boxes of envelopes and 4 boxes of notepaper. Again, I don't know what it costs, so it's going to be X. I don't know what the note paper costs, so it's going to be Y dollars. And in order to get my equation, here is 1075. I'm going to do the same thing here, multiplying down, adding across. Multiplying down, 3 times X will give me an equation, 3x plus 4 times y, 4y, equal to a total of 1075. Okay, what we have here is our systems of equation, our two equations that we have in order to solve our two variables. X, which represents the cost of envelopes of each box, Y, which represents the cost of each box of note paper. Okay, and we're going to use these two equations now in order to solve for X and Y. What I'm going to do is I'm going to transfer these two equations onto a separate sheet of paper. 5x plus 6y equals 1675 is my first equation. My second equation is 3x plus 4y equal to 1075. Now, you can use any method you'd like in order to solve the systems of equation. What I'd like to use here is elimination. And I can't use addition. I'm going to need to multiply both equations in order to eliminate one of the variables. And I think for this example, I'll choose to eliminate x. If I am eliminating x, what I'll want to do is multiply the top by 3, and I want to multiply the bottom equation by a negative 5. Okay. When I do that, what I will have is distributing that 3 across the entire equation. My new equation will be 15x plus 18y equal to, and I'll have to do this math out on the side. I encourage you to do the same. 15, 3 times 7 is 21, plus 1 is 22. 3 times 6 is 18, plus 2 is 20. 3 times 1 is 3, plus 2 is 5. There are 2 decimal places, so $50.25. Okay, the second equation, we're going to distribute the negative 5 across the entire equation, giving me a negative 15x minus 20y equal to, and again, I will do the math out on the side. 5 times 5 is 25. 5 times 7 is 35, plus 2 is 37. The 3, 2 decimal places, so 53.75. Okay, now I have my additive inverses, so I know I can just add the two equations to eliminate x. I'm left with a negative 2y equal to, oh, I forgot my negative sign. Okay, when I multiply the negative 5 to the $10.75, it's a negative times a positive, so I should have my negative sign there. Please double check that you have the same. Okay, so now we are adding a positive $50.25 to a negative $53.75. And I always ask myself, is it going to be more positive or more negative? In this case, it's going to be more negative. And I ask myself, well, how much more negative is it? To find out the answer to that question, I'm going to have to subtract to find the difference. How much more negative? In this case, it is $3.50 more negative. So $3.50 more negative. Dividing by a negative 2, y in this case will be equal to $3.50 divided by 2. Remember to show your work every step of the way. Okay, so 2 goes into 15 7 times. $1.75. Okay, I put a dollar sign there because y, well, the value of y, if we went back to our setup, y represents the cost that dollar sign, that cost of one box of note paper. Okay, so once we find y, though, we need to find out what x is. In order to find what x is, I'm going to plug it back into one of my original equations. Let's plug it into 3x plus 4 equal to 1075. Multiplying this out, I will get $7. So 3x plus 7 equals 1075. And to solve for x, I will subtract 7 on both sides. 3x will be equal to 375. And dividing by 3, x will be equal to, again, let me move this forward. 1, 2, 5. And my decimal point moves straight up. X is $1.25. Okay, so of course I want to make sure I answer everything in a complete sentence. So your money problem, the cost of 5 boxes of envelopes and 6 boxes of note paper is $16.75. 3 boxes of envelopes and 4 boxes of note paper will cost $10.75. Find the cost of each box of envelopes and each box of note paper. I can say each box of envelopes is X. So I know that when I solved for X, it was $1.25. And each box of note paper costs $1.75. Okay, make sure that we answer the question that is being asked at the very end. Okay, you will have another example to work with. Example number 2. 2 pairs of jeans and 3 shirts cost $1 or 133. The cost of 3 pairs of jeans and 6 shirts is $231. Find the cost of each pair of jeans and each shirt. What we'd like to do here again is set up your 2 equations. I'm going to pause here to see if you can set up the equations yourself first. Okay. So if you're thinking about the shopping cart analogy once again, we are shopping for jeans and shirts. Okay, 2 pairs of jeans and 3 shirts total will cost $133. Okay, we don't know how much it costs and we don't know how much this costs. So when we set up our equation, we will get 2x plus 3y equal to 133. Okay, I'm not going to draw the picture for the second sentence, but if you translated it, you should get an equation that reads 3x plus 6y equal to 231. So continuing with this example, were you able to solve the systems of equation? If so, you might have chosen to use elimination. Okay, if you're using elimination, I would go ahead and try to eliminate the x variable. So I would multiply the top equation by 3 and the bottom equation by -2. Once you multiply these, you will get 6x plus 9y equal to 399. And multiplying the second equation, you'll get a -6x minus 12y equal to a -462. Now that I have my additive inverses, I can go ahead and combine the equations, which will eliminate x, leave me with a negative 3y, and a number that is more negative by, subtract to find out how much it's more negative by, 63. If I divide by 3, I will get my solution for y. Dividing by 3, I will get a negative. Divided by negative is a positive 21. And what does 21 represent? 21 is y, and 21 is the cost of the shirt. So I'm going to go ahead and put the dollar sign on there to remind me. Okay, now that I have y, I can replace, substitute in for the original equation. So I'll pick the first equation. 3 times 21 equal to 133. 3 times 21, we know 63. So to solve the equation, I'm going to subtract 63 on both sides. 2x will be equal to 70. Dividing by 2, x will be equal to 35. And again, this is in dollars because x is the value of the cost of your jeans, each pair. So let us write our sentence to complete. The cost of each pair of jeans, is represented by x, is $35. The cost of each pair of shirts, well, each shirt is $21. Okay, so there we have our solution. That's it for money problems. Check back in tomorrow for the